So in this video we're going to take a look at how to write a light controller in TIA. This video is not intended to be for brand new beginners, so if you're brand new to TIA then maybe this isn't the best place to start, but sometimes I thought it might be useful to show people how to kind of write a controller function so that you can control a light in different states. So sometimes you might have a single light that needs to be on, then off again, then it might need to flash, then it might need to flash at a different frequency. And if you need to keep track of all of these different things, then really a controller is a nice way of doing that. So I wanted to show that. So what we will do is we will get started. Here we're not actually going to run the code at the end of this, we're just going to write it and talk about it. But we have a PLC here, and I've got a basic function program going on here. So this is a kind of case structure program. It'd be a typical one what you would write, where you would have a step sequence and you'd basically be going through all the different steps in the program. We're not going to worry too much about that, but I've just scaffolded that so that we have it ready to do this tutorial with. So of course in your main program you would have your program that would be running in there so that this runs all the time. So let's talk about how we might add controllers to this project and what we might do. So the first thing we're going to need is somewhere for these controllers to go. So they could go within our main object, but I think it's going to be better to put them into a new modules organization block. So I'm going to create one called modules. Ladder is good. I like ladder for my organization blocks, and it just sits here. So both main and modules run all the time, of course, while the PLC is running, but program only runs because it's included inside of main, and the controllers that we're going to write, we're going to place them inside of modules, and that's where they'll run. It just kind of keeps everything separate and nice and clean. So let's start. We're going to write a generic controller that can be used again and again and again for lots of different lights. So we're going to come to add new block, function block, and I'm going to write my controller in SCL. You could write it in anything really, but SCL makes the most sense to me. And I'm going to call this light controller. Okay, so we're inside light controller. So because this is a kind of a state machine, something that can be in multiple different states, I'm going to start by creating here a state, and it's going to be an integer. And this is what we're going to use to jump between our different states. We're going to create a case structure here, and it's going to be based on state. There we go. And we need to kind of decide what these different states should be, right? So 0, for me, it would make sense that this means off. Then we could have state 1, and I think for me, it would make sense that this is on. And then we can think about the other ones as well. So let's say we've got a 1 Hertz light and a flashing at 1 Hertz and flashing at 2 Hertz, or maybe at 0.5 Hertz, 1.5 Hertz. So for me, I think I would just do these as like 5. So 5 would be our, 5 would be our 0.5 Hertz light. Then 10 can be our 1 Hertz. And maybe 15, if we need it, can be our 1.5 Hertz, and 20 can be our 2 Hertz. It doesn't really matter what you do here, because actually we're going to perhaps hide this and manipulate this a little bit later so that we don't need to remember these numbers. But for now, this is where we're going to start. Okay, so what we're going to want to do is give an output to our light controller. So I'm going to come up here and I'm going to put this and call this light light output. That's going to be a boolean. That's what's going to be actually tagged to our real light. And then we're also going to create another static variable here, which is going to be light state, and that's going to be a boolean. So we've got light output and light state. Technically, we could probably get away without the light state one, but for me, I like to have it. And what I like to do here is at the very bottom of the controller, I like to make sure that the light output is assigned the value of the light state. And then as we go, light state should be boolean. As we go through our controller, the light state is what is changed and updated. So for example, this means that in our state 0, we will have our light state to be set to false, And in our step 1, we will have our light state to be set to true. Right. So now the clocks. I think we probably need to enable the clock bits here. So if we come here to our PLC, okay, we have to actually specify a PLC here, I think, in order to do the clocks. So I might need to, let's see, I might need to just change the device and set something specific. I'm going to assign a specific type of PLC here. We're not ever going to download, so we really don't care about the protection here. Okay, so we can now come on here to the system clocks and we can enable the system clocks. Great, so we've now got all our system clocks here on these memory bits. And like I said, we've got our 0.5 hertz, our 1 hertz, 1.25 and 2.5. These are the ones we're mainly going to use here. Okay, so these are enabled. This is important. And once we've enabled the clock, we sometimes need to do a compile. So we're just going to do a full compile here. Okay, yes, turn off the password control. Compile hardware and software. Wonderful. Okay, there's enough going on there that it should work for us now. So we're going to jump back into our light controller here. And now, at this point, we can set light state to be equal to, hopefully we will have, has it got it yet? No, it still hasn't got it. Okay, let's try and fix these compile errors. Does not want to compile. Can we just compile the hardware? Then will it let us do it? Come on. Yes, compiling is finished. Okay, therefore we should have PLC tags. We do, they're all here. Okay, so therefore in our light controller we should be able to specify them. There we go. Maybe I was just using the wrong ones here. Where's my 0.5 hertz? It's there. M0.7. Let's copy it directly into here. Perfect. So we have our 0.5 hertz. This is going to be our 1 hertz. This is going to be our 1.5 hertz. Does 1.5 hertz exist? Nope, maybe not. Okay, let's get rid of it. And 2 hertz. This definitely exists. There we go. So we've got 5, 10 and 20. That's fine for me. So now when we are using this, we come to our modules, we bring in our light controller. Actually, we need a light control first, so let's go to our default tag table. Let's create a new one, actually. And we will call this indicator 1. Okay, we're going to come back to our modules. We're going to drag our light controller in, and we're going to call this indicator 1 DB, or indicator 1 controller, if you like. So we have indicator 1 controller. The output will go to indicator 1. And then within our main program, if we wanted to change the light state, all we need to do is say we want indicator 1 controller dot state, and then we say, okay, if we want it to go on, we say 0, for example, and then it off, we say 0, and then maybe later on in the program we want it to come on, and we would say 1. Go away. And if we wanted it to flash, then we could come in here and we could say, okay, we want it to go to state number 20 if we wanted it to flash at 2 hertz. But the kind of issue is that you can't really tell what's happening here, right? There's no kind of support for what this could equal. We can kind of help a little bit by coming into our light controller and adding some comments, right? So if we come over here to our comments, we could come over here and we could say, okay, 0 is equal to off. We could say 1 is equal to on. We could say that 5 is equal to 0.5 hertz, for example. And if we might as well do the whole shebang here. 10 is equal to 1 hertz, and 20 is equal to 2 hertz. Okay, so now if we've got that in a comment, and we come back into our program, we might get a bit of a hint here. Let's see. Is it going to help us out here? Possibly not. No. Oh, if we hover over long enough, will it tell us? There we go. So if we hover over, it does tell us what we could set stuff to. So that makes life a little bit easier. But really, it would be nice if we could have it kind of actually typed out what we want to do. And so this is where it starts to get a little bit more advanced. But what we can do is we can come into our light controller and begin to think about this again. So this is our kind of actions, right? These are our possible states. And so I'm going to put this into a region, and I'm going to call this states. Okay. And then at the top here, I'm going to create a new region, which I'm going to call actions. Okay. And I'm going to add a new row to my controller, and I'm going to call it actions, and I'm going to make it a struct. And under here, I'm going to create action Boolean variables for each one of these possible states that is named in kind of a way which makes sense for us so that we can read it really easily. So I'm going to start with off, and then on, and then we'll do 0.5 hertz. Can I have dots in this? Yes, we can, apparently. 1 hertz and 2 hertz. Okay, so these are our actions. And then up in the top here, what we're going to do is we're going to write some if statements. So we're going to say if actions dot on. Well, we'll start with off. Then the first thing that we need to do is to turn actions dot off to false. And then the second thing we need to do is change the state of this controller to go to 0. Okay, so why are we doing this? This means if someone turns on this Boolean, this top region will be true. We will turn it off again and jump to step 0, which means that then the state machine will be in step 0, but it kind of only jumps into that state just one time. This is kind of important that we have this here, because otherwise what happens is if we turn off on, then it stays on forever. The off variable stays on forever. I appreciate I'm confusing myself here a little bit with the terminology, but it's because we're off and on at the same time. We can do maybe another example here if we add in the on, and then perhaps another one here if we add in something like the 0.5. I think we might need to put these in braces like that. Okay, because it's got a dot in it, we have to put the braces in place. There we go. And so this one flashes to 1, and this one jumps to 5. And we've just got 2 more to do, don't we? We've got our 1 hertz and our 2 hertz. So this one here is going to be for our 1 hertz, jumping to 10. And then this one here is going to be for our 2 hertz, and it's going to jump to 20. Okay, so where are we at? We should now have everything that we need in order to get this to work. We should be able to come back to our program, and now instead of referencing this via state, what we can do is something much more interesting, because we can say indicator1 controller dot. I'm going to have to update it. Come here and update the block call. Come back to our program. There we go. Now we should get actions. It's there. Dot. And then you can say exactly what you want. So on is equal to true. And now that light will be on. If I wanted to do something else with it later, I could come here and I could say, okay, we want it to be off at this point. We just set off to true. So we're not kind of turning the light on off using these true, we're setting the action off to true. And as soon as we do that, it triggers everything to work. And if we come down here to something else, maybe later on, okay, this is going to have to be in quotes because of what it is, but we can do 2 Hz to true, just like that. So really what we're trying to do here is kind of almost simulate it like if this was another programming language, you'd think of these as functions, right? You could do something like that, where you are, if I just make this a little bit bigger, you are kind of calling like the off function. We can't do that into here because there's no way of having functions kind of passed as structures. You can't really do that. But this is a pretty good proxy for doing it because you're essentially just calling a function in this way. And we've kind of written micro functions within our controller. And each one of these functions only runs once. It runs a single cycle. And as part of the small function that it does, it jumps across into a different state, and then it just stays in that state. And of course the output is wired here. This is really nice, and the beauty of it, of course, is because it is a controller, you can reuse it again and again and again. So if we wanted to have a second light, for example, so we've got indicator 1, let's say we have start light, for example, which is another tag. I guess these should both be Q0.0 and Q0.1. They should be outputs, I suppose. Not that it really matters here. And we could bring another light controller in. We could call this start light controller. We attach it to our start light. And then, again, in our program that we've been writing, of course, we can now have our start light controller .actions .2 Hz to true, and it could stay flashing the whole time if we wanted to, or it could turn off later on in the program. Anyway, I hope this has been a useful introduction to how you might want to do this, how you might do controller programming. As always, there's many ways of doing these things. This is just one method that I found particularly helpful and quite versatile, because it means if I needed to in the future to go in and add different frequencies or different flashing patterns, then it's quite easy to do that. So yeah, hopefully this has been useful. Hopefully you've learned something. See you next time.